All right, hello pre-cal. This is lesson 9.3, nonlinear systems. So today we're going to be solving systems involving quadratic and linear equations. So linear means we've got a line, and quadratic, that's anything with x squared as its highest degree. And so we have a parabola type shape. And so you can see that if we have a system of equations, so two equations, what could happen is there are 2 points of intersection. There would be 2 solutions. And so that'd be 2 ordered pairs where those 2 equations would intersect. But you could also potentially have a line and then a quadratic function above, and there might be no solution because there's no intersection points. Could you have one solution? Sure. You could have 1 point of tangency. This would be one solution. And that's called a tangent line. All right, that's what that's called. Tangent, you might remember that word from trigonometry, right? Sine, cosine, tangent. But tangent literally means two. And so you can see that our tangent line is just touching that parabola in one spot. So there's one ordered pair solution there, one solution for x and y. Let's see how to do it algebraically. So the nice thing is you can solve these things graphically when you've got y by itself. So you could plug these into your calculator in y1 and y2, and you could graph them and then calculate the intersection using your calculator. So that's a thought. You could do it. We'll do that a little bit later, I believe, specifically. But for now, you'll notice that they're both set equal to y. So what we're going to do is we're going to use substitution. The substitution method to solve. And substitution literally means to substitute. So what we're doing here is we're saying, hey, y is the same as negative x plus 4. So I'm going to take negative x plus 4 and I'm going to plug it into the other equation in place of y. And what you might say is, oh, well, some teachers might say we're just going to set them equal to each other. If A equals B and B equals C, then A must equal C. That's the transitive property from geometry. But really, if they're both equal to y, aren't they both equal to each other? Doesn't that make sense? All right. And so then, now you'll see we have this quadratic equation. So we need to set this equal to 0. So I'm going to add x and subtract 4 so that these disappear from the left-hand side and become set equal to 0. So we have x squared minus 12x and then plus 20. And let's see, then we can double bubble, factor and solve. So set equal to 0, factor, and solve. And so, let's see, x times x is x squared. X times x is x squared. What times what is positive 20? 10 and 2. Oh, 10 and 2. Look at that. All right, so negative 10 and negative 2 give us that negative 12. And then we can solve by solving for x. We get x equals 10 and x equals 2. Now, you're not done because these are just x coordinates. Remember, this is a parabola and a line. And so we need to find what are these ordered pairs where they intersect. So we need to figure out the corresponding y value. Well, I know that if x is 10, I have a way to figure out y. And you can use either equation, top or bottom. This one's simpler. So y equals negative x plus 4. So I'm going to go ahead and plug 10 in there. So we'd have negative 10 plus 4, which means y equals negative 6. So one solution is 10 for the x, negative 6 for the y. Here again, we can take our second equation and plug in the 2. So we have negative 2 plus 4, which then would give me 2. So the ordered pair 2, 2. Ordered as in alphabetical order. So there's your two ordered pair solutions. All right, what's different about letter B here? This was easy when they're both solved for y. So if that's an option, we want to solve for y. Get y. Solve is a bad word. Isolate. Isolate y. That's a better way to say that, I think. So if you have an option, this is easy to get y by itself. So let's isolate y. Let's subtract 3x to the other side. So then we have y equals negative 3x plus 12. Now y is by itself, and I can plug in to that other equation. So we have negative 3x plus 12 equals negative x squared minus 10x plus 12. And again, now we want to set it equal to 0. I'm going to go ahead and add 3x and subtract the 12. So we remove the terms from the left-hand side. Have negative x squared, negative 10 plus 3 means the negatives win, and that becomes 0, which is nice. Now, how do you solve this? We want to factor. What is the most forgotten way to factor? Greatest common factor, GCF. I'm going to take out the negative x. If I undistribute the negative x, I'd be left with x plus 7. How do you know if you did it right? Check by distributing. Negative x times x is negative x squared. Negative x times 7, negative 7x. All right, so it's factored. And then we can set each factor equal to 0. So negative x gets set equal to 0. X plus 7 gets set equal to 0. Well, divide by a negative. X is just 0. And here, x is negative 7. And again, we're not done because we need to find the corresponding y value. So again, I'm going to go back to this equation so that I can figure out the y. So negative 3, plug in a 0, plus 12 means y is 12. So my ordered pair would be 0 for x, 12 for y. Over here, plugging in to my y equation, we have negative 3 times x. My x in this case is negative 7 plus 12. That gives me 21 plus 12. And so I would get y equals 33. So we would have negative 7, 33 as an ordered pair. It's always a good idea to check your answers. Of course, the best way to check is to take your x's and y's and plug them in. And just check for balance. Do the equations balance like they should? All right, a couple more here. Letter C. Again, this has y already by itself, and so we would want to get y by itself here. It's negative. I'm actually going to go ahead and add y. So it's positive. That would give me y plus 3 equals 2x. And then I'm going to go ahead and subtract the 3. So just doing a little trading of sides here, I get y equals 2x minus 3. I need my y to be positive. So that's really important. So this is my equation that's simple that I can use. Y is the same as 2x minus 3. So wherever else I have a y, I can plug it in because those are the same. So we have 2x minus 3 is equal to negative 2x squared plus 28x minus 75. Again, I'm going to set it equal to 0. I'm going to subtract 2x. I'm going to add 3. So I get a 0 on the left, negative 2x squared. Let's see, that's going to be positive 26x. And 75 minus 3, that'd be 72. Ooh, these are big numbers, right? But I noticed that every single term is even. So I can divide by 2. And in fact, I'm going to divide everything by negative 2 because I do not like factoring when there is a negative in front. So I can do that because we're set equal to 0. I can divide and multiply all day long. I'm not going to change anything. It's just going to reduce our numbers, which is nice. So negative 2 divided by negative 2 is just x squared. 26 divided by negative 2 would be negative 13x. And 72 divided by 2 36, positive 36. Oh, those numbers are much better. Now we can factor. X times x is x squared. What times what is positive 36? 9 times 4. Negative 9 times negative 4 gets me my negative 13, which means x equals 9 and x equals positive 4, and we can plug back into our very special equation to figure out the corresponding y value. So 2 times 9 minus 3, 18, 17, 16, 15. So we get 9, 15 for our ordered pair for one solution. Over here, y equals 2, plug in a 4, minus 3, that'd be 8 minus 3, which is 5. So we'd have 4, 5 as our ordered pair solution. All right, one more. These are already solved for y. Well, that's kind of handy. All right, let's see. X minus 4 is going to equal 10x squared plus 10x minus 11. Set equal to 0. So subtract an x. Add a 4. So we get 0 equals 10x's squared. 10 minus 1 is 9x's. Negative 11 plus 4 is negative 7. Oh, Lord. All right, I've got to double bubble this. This is why I had to do this. This is a hard trinomial because we've got a number in front. Makes it a little more challenging here. I can't divide. It's not even numbers, so I can't do that nice little trick. But remember, first times first has to be the first thing. What times what is 10x squared? 5 times 2. 5x times 2x. So let's go with it. 5x times 2x. And last times last has to be negative 7. What times what is negative 7? We do not have options because 7 is prime. So it's 7 and 1, or negative 7 and 1. Let's see. If I put a 7, let's put the 7 on the inside. Positive 7 on the inside. Negative 1 on the outside. How do you know if you did it right? You check the rainbow. Remember, check the rainbow anytime you have a number in front, a leading coefficient. Here we would have negative 5x, and on the inside, 7 times 2 is 14x. And what is 14x's minus 5x's? That is where the magic 9x comes from. So I like doing those just to refresh your memories. So here, 5x plus 7 gets set equal to 0. And 2x minus 1 gets set equal to 0. I'm going to subtract the 7 and divide by the 5. So we get a fraction. Here we are going to add the 1 and then divide by the 2. So we get, again, another fraction. Okay, that's why these are a little more tricky. We're getting some rational fractional answers. So we can do that. Negative 7/5 plugs in place of x, and then subtract 4. Well, fractions, I'm going to do this work right now because it's important in this level. Get a common denominator multiplying by 5, so that would be minus 20/5, and so we would have negative 27/5. So our ordered pair would be negative 7/5, and for y, negative 27/5. And you would want to reduce if you could, but those do not reduce. Let's see, plugging in the 1/2, that's a little easier. 1/2 minus 4, again, that's 4 over 1, and we're just going to multiply by 2 to get a common denominator. So that's 1/2 minus 8/2. 1/2 minus 8/2 is negative 7/2. So that ordered pair is going to be 1/2 for x and negative 7/2 for y. And that is some great, ordered pair action. Okay. Great math right there. This is like really good math. Love it. So much fun. Ladies and gentlemen, you have Delta Math 9.3. Have a great day.